Welcome back, everyone. Hope you're ready to dance with this beautiful cube root function. We're talking transformation of functions now. This would be the first in a series of 3, and we will do some vertical transformations here. So as you can see, I have a cube root function here, and I've just chosen some perfect cubes, -8, and the cube root of which is -2. There's a -1, cube root of which is -1, 0, it stays as 0, 1, and the cube root again here is a +1, 8 with a cube root of 2. So those are my perfect cubes, and of course I can extend this beyond those points on both sides. So that's what this one's going to look like. Although we're talking cube root functions in this video, we could have chosen just about any function family. We could have done an absolute value, and an absolute value would have looked something like this, like a V shape. We could have chosen a square root function that would have looked like this. So what I will do is I'm going to use this blue button here, and I'll say that's my function, because I want to be oblivious to this fact. I don't want to get into the specifics of the function that I'm really using here, because vertical transformation is all about what you do outside this box. Okay, so we're going to keep this little button here as the function, and then the transformations that we do would be either an addition or a subtraction, or a multiplication, which is called the scale or dilation factor, or a sign change. These are the 3 vertical transformations: a reflection, a dilation, and a translation. Okay, so having said that, let's move on. Let's start. As we can see, the navy blue one here, the little snake you see here, is our parent function, the cube root function. The first transformation we can do is we can decide to add 5 units here. Okay, so let's add 5. Again, I'm going to keep this covered just so that you can visualize that, this is really just about any function. So if I do a +5, what does that mean? That means I need to add 5 to the y value of each of these points, right? So if I had a -2 here, I'm going to add a +5, and that gets me here. I'm going to add a +5 to this -1, that gets me here. I'm going to add 5 to my 0, that gets me here. These are all, I'm just extending everything by 5 units. The 1 comes up to a 6 because that's 1 + 5. Likewise, the 2 comes up to a 2 + 5. Yeah, something doesn't look right here, right? 2 and 3, 4, 5, 6, 7. This is where this point should be. Okay, so having said that, now let's actually look at this function. What do you think this one's going to look like? So let's make sure I have all these points: 1, 2, 3, this one, and then this guy. Okay, of course this can again be extended on both sides, and that's what this one's going to look like. So what do you think? What have we really done over here? Okay, it's as good as me lifting this original guy and placing it further up, right? So I'm moving all these points by 5 units. So it's a +5, which means even this point is displaced. All these points have relocated. They've all gone up 5 units. So like I said, I could have just pulled this up and placed it here. What if it was a negative number? Instead of doing a +5, what if I had, let's say, a -2? I would have done just about the same thing, but I would have taken this down. So a plus would get me up, and a minus would get me down, right? So that's the only difference. But this is a translation where I'm physically, you can imagine this as me physically moving the original one up or down. On the y-axis, we're talking vertical transformation, right? So everything I'm doing outside the button is vertical. Next, let's try another thing here. Let us, how about we reverse the sign? Okay, so I'm going to put a minus here. Again, the function as such doesn't matter, but I'm going to make it negative. So let's look at this. Is my original one. If I make it negative, okay, which means if I had a -2, I'm not changing the value, I'm just reversing the sign. So if I had a -2, that becomes a +2. If I had a -1, that becomes a +1. 0 remains where it is. 1 would become a -1, and a 2 would become a -2. So now if I were to plot this for you, let's actually use this one, okay? It would look somewhat like that. Correct? I mean, yeah, not the most beautiful shape here, but I hope you get the idea. So see how everything's reversed. The spiral is kind of reversed. You see here and here. Again, if you notice, this is vertical, okay? We didn't do anything on the x-axis at all. We didn't stretch anything out. So far, first we moved up. This second one where we reversed the sign, we just, it looks like a proper spiral now, right? Okay, so that's what happened. That's our reversal of the sign. That's the reflection. Next, let's do a multiplication. So how about I say I want to double, okay? Of course, what we're doing right now, please don't look at it as a composite set of operations, which means we're not doing it in this sequence. We're doing either or. We first just did a plus or minus, then you can imagine that this is not there. Next, we did the reflection. You can imagine again, it's independent of what we did previously. And likewise now, if I am doubling, you can just assume that I don't have these, okay? We can do composite functions that we'll do in the third video, once we've covered horizontal as well. So we'll do one problem then where we would include horizontal, vertical transformations, and we'll do it in sequence. But for now, let's just focus on the concept. So coming back, now if I want to double this, okay, what do you think? Here again, coming back to the original one, okay, doubling would mean I'm making it bigger, but I'm not really relocating it. So let me show you what I mean over here. Okay, here we go. So what that means is 0 times 2, okay, 2. So 0 times 2 remains 0. So this original one will stay where it is. 1 minus 1 minus 1 minus 1. What do you think that'll become? Minus 1 times 2 minus 2. So that would be here, okay. What about this other one here? Minus 8 minus 2. So the minus 2 times 2 would make it minus 4. That would come here. So we had a minus 2, we had a minus 4, 0 remains where it is. The plus 2 likewise would be, sorry, the plus 1 would become a 2 because I'm multiplying everything by 2. And this would again become 2 times 2, 4, correct? So that's what this would look like. So you see everything remains the same. It's just like this. The position, the main center doesn't change, but it's all much bigger than before. It's dilated, it's stretched out. So that's what we had in this video. I wanted to cover vertical transformation, and we will next move on to horizontal transformations and do a do a problem or a couple of problems where we cover everything together. Thank you. I'll come back soon.